Good morning, good afternoon, or good evening, depending on when you're watching this. Now, we're going to look today at the exponential function and the logarithmic function in Unit 3. Now, we did meet them earlier, we met them in Unit 1. And let's look at some reminders of the work that we covered earlier in Unit 1. We looked at the exponential function, f of x equals a to the power of x, base a. Now, we started by looking at the exponential function base 2, and that was f of x equals 2 to the power of x. And we actually drew this. If we took the values of x from negative 2 to 3, all the values in between, we took the whole numbers, and we wrote in our domain negative 2, negative 1, 0, 1, 2 and 3 were the elements we took in the domain, although it was everything in between negative 2 and 3. And we wanted to see what elements would they map to in the range. And to do that, if our function is f of x equals 2 to the power of x, to get the image of f of minus 2, it would be 2 to the negative 2. Now remember, that's 1 over 2 to the power of 2, which is 1 over 4. So in the domain we have negative 2, and its image in the range is a quarter. So negative 2 is mapped to a quarter. And we did exactly the same thing with each of these. 2 to the negative 1, 1 over 2 to the power of 1, a half. F of 0, 2 to the power of 0, which was 1. So we got these values there. And that gave us this function 2 to the power of x, an exponential function base 2. Now, it's a one-to-one correspondence, and remember when we did functions, we said if you had a one-to-one correspondence, that had an inverse. And in that inverse, what had been the range became the domain, and what was the domain became the range. So this is a one-to-one correspondence, the exponential function base 2. And again, in Unit 1, we said there is an inverse. It's a logarithmic function base 2. So the inverse function, log x to base 2. And what was our range becomes our domain. So a quarter, a half, 1, 2, 4 and 8. What was our domain becomes our range. So negative 2, negative 1, 0, 1, 2 and 3. Now we said that the inverse function is the logarithmic function, log x to base 2. So when we're getting the image of a quarter, it would be f of a quarter is equal to log a quarter to base 2. So we know that log a quarter to base 2 is equal to negative 2, and that's what I've written at the side here. A half, f of a half, would be log a half to base 2. And so log a half to base 2 is equal to negative 1, and I've written that over here. And we've followed that all the way down. Log 1 to base 2 is equal to 0, and I've written that there. Log 2 to base 2 is equal to 1. So we've ended up with all of this here. Okay, now let's have a wee look-see. Can you see, if we start down here, we'll start at the bottom and work our way up. If you're trying to get a value for log 8 to base 2, then can you see, if we look at 2 to what power is equal to 8, 2 to what power is equal to 8, that's 2 to the power of 3. So that's what you're doing here. This is base 2, so when you're looking at 8, you're saying 2 to what power gives me 8, and it's 3. That's where that's coming from. Here, if we were asked to work out the value of log 4 to base 2, then what you're looking at here is 2 to what power gives me 4. And it's 2, so that would be 2. So that's all we are doing here. Here, we've got log 2 to base 2. So if you're trying to work out log 2 to what to base 2, then you have got 2 to what power is equal to 2. And it's 2 to the power of 1. And we could go, let's go up here. We've got log a quarter to base 2. So if we were going to work that out, log a quarter to base 2, then what you're looking at there is 2 to what power gives me a quarter. And it would be 2 to the negative 2, which is where that's coming from. Here, if you were asked to work out log of a half to base 2, then base 2, 2 to what power is equal to a half? And it would be 2 to the negative 1, which is where that's coming from. And here, log 1 to base 2, 2 to what power would give me 2 to what power would give me 1. and it's 2 to the power of 0. So that's where that's coming from there. Okay, so that's all we have there. Okay, so look at what we have. Exponential function base 2 is 2 raised to a power. The logarithmic function base 2 is what the inverse is what power has 2 been raised to achieve your answer. If we had exponential function base 3, then the exponential function is 3 raised to a power. Logarithmic function base 3 is what power has 3 been raised to achieve your answer. The exponential function base 10 is 10 raised to a power. The logarithmic function base 10 is what power has 10 been raised to get your answer. So let's look at this here. Log 8 to base 2. What we would be looking at there is 2 to what power is equal to 8, because this is a logarithmic function to base 2. So what power has been 2 been raised to give us 8, and it's 2 to the power of 3. So that is 3. Here we have log 81 to base 3. So logarithm base 3, what power has 3 been raised to give us 81? So 3 to what power is equal to 81? And it's 3 times 3 times 3 times 3. Now you can check that out if you're not convinced. 3 to the power of 4 is equal to 81. So that is equal to 4. Here, log 100 to base 10, now it's base 10. So what power has 10 been raised to? 10 to what power is equal to 100? It's 10 to the power of 2, 10 squared. So that value there is equal to 2. This one here, log 125 to base 5. What power has 5 been raised to? 5 raised to what power gives us 125, and it's 5 to the power of 3. So that would be 5 to the power of 3. So that value equals 3. Now let's look at that again. If we had log 100, which we have there, log 100 to base 10 is, if we said that was equal to x, then what we would be saying then is, if we could write that as 100 is equal to 10 to what power? And it's 2. So you have to be able to write it in logarithmic form and in exponential form. So log 100 to base 10 is equal to x, and that is 10 to what power? 10 to the power of x is equal to 100. So you've written it in logarithmic form, and then you've written it in exponential form. Now, let's look and see if we had, can we go the other way? If we had log y to base a is equal to x. That's it written in logarithmic form. Log y to base a is equal to x. If I wanted to write that as in exponential form, then it would be, what power has a been raised to? Y equals a to the power of x. So given it in logarithmic form, you have to be able to write it in exponential form. And also, if you have y equals a to the power of x, then you have to be happy that that is log y to base a is equal to x. So you have to be able to go between these forms. Okay, really, really important that you can do that. If you've given it in logarithmic form, then you can write it in exponential form. And if you're given it in exponential form, then you can write it in logarithmic form. Now, let's look at some very important examples that arise from that. If I can write down 1 is equal to a to the power of 0, and that's true, 1 does equal a to the power of 0, then writing that in logarithmic form, that would be log 1 to base a is equal to 0. Now what that's saying is log 1 to any base is equal to 0. So we have log 1 to base 10 is equal to 0. Log 1 to base 2 is equal to 0. In fact, log 1 to absolutely any base, log 5. Log 1 to base 5, let's rub that out. Log 1 to base 5 is also equal to 0 as a result of that. Now again, here we could write a is equal to a to the power of 1. That's it written in exponential form as a logarithm. Log a to base a is equal to 1. And again, that would be log 10 to base 10 is equal to 1. Log 7 to base 7 is equal to 1. Log 9 to base 9 is equal to 1. These are hugely important results. Let's record them again, these two very important facts. If we had log 1 to base a, it's equal to 0, and log a to base a is equal to 1. You will have to write these on your heart and remember them. They're going to be used a lot in this chapter. Now you can check out this on your calculator. Your calculator that you have has base 10. Now your button that's got log on it is your calculator is set to log base 10. So if in your calculator you press the button that's got log on it and you press 1 equals, you will get 0. But that's for log base 10. So here, if you checked on your calculator, log 10, remember it is base 10, so base 10, you should here, log 1 to any base is 0. Log 10, because it's base 10, you will get 1. And you have to write these facts on your heart for later, really. Now let's look at the examples we have here. Simplify log 64 to base 4. Now what we said was that is 4 to what power? 64 equals 4 to what power? That would be our answer. And it's 4 to the power of 3 because 4 times 4 is 16 times 4 is 64, so that's 3. But I'm going to write this down as let it equal x. And you can see 64 equals 4 to the power of 3. Taking that out of logarithmic form, that would be 4 to what power gives me 64. So 64 equals 4 to what power? So really that's what I've got here. X is equal to 3. So we're going to set it down like that. Log 32 to base 2, I'm going to let that equal x. Taking it out of logarithmic form, this is log 32 to base 2. So 32 is equals being raised 2 to what power? 2 to what power gives me 32? 2 to the power of 5 gives me 32. 2 times 2 times 2 times 2 times 2. Here, log 1000 to base 10, again I'm going to write equal to x. That's it in logarithmic form. I have to be happy writing it in terms of an exponential. Base 10, so 1000 is equal to 10 raised to what power? 10 to the power of x. X is equal to 3. Here, log 1/9 to base 3 is equal to x. So again, 1/9 is equal to 3 to what power? Again, this business of can you take it from a logarithmic form and write it as an exponential? Well, 3 to the power of negative 2 is equal to 1/9. So x is equal to negative 2. Now, second one, can you take it from logarithmic form and can you take it from exponential and write it as a logarithm? Y is equal to 7 raised to the power of 4. So if we were going to write that in logarithmic form, it would be log y to the base 7 is equal to 4. 7 raised to what power? Okay, so that's it written as an exponential, that's it written in logarithmic form. Here, 4 equals a to the power of b, so log 4 to base a is equal to b. Here, 1 equals 6 to the power of 0. Log 1 to the base 6 is equal to 0. And that's not surprising, we've got that result there. Here, this would be log 1/9 to the base 3 is equal to negative 2. And that's what we've done there, the reverse there. Okay, thank you very much.